Hi, everybody. My name is McNiece, and today I'll be presenting our work characterizing the security of endogenous and exogenous desktop application network flows. Understanding how applications use the network affects the security of the user, the system, and the enterprise. Understanding at scale if desktop applications use the network securely is hard because the application provenance of a given packet is rarely available at a centralized collection point. As we kind of see in this picture below, applications generate their own network traffic. At the device level, we can see which applications are generating what traffic, but as that goes to the network, we lose that detail. By putting our collection point on the host, we're able to maintain that granularity. And our second challenge is that we need to be able to differentiate between the things a user does versus the things the application does. We call this exogenous versus endogenous traffic. This is a term we borrow from biology, where exogenous would be something that comes from outside of some organism, where endogenous would be something that comes from within. There's a number of research questions we explore in this paper. We're going to focus on 3 during this talk. How many of an application's connections are endogenous? What applications are not using secure ports? And are applications communicating with reputable domains? So first, let's talk through how we did this. So we started with 24 hours of data from about 40,000 IT-managed devices on a Fortune 500 network. These devices generated application and OS configuration information, as well as application labeled netflow. We collected both of these things and put them into our anonymizer process that removed all human identifying information. From this set, we got 3.2 billion flow records over this time period. We also collected DNS queries from all of these hosts at a central point in the network. We only kept the resolved IP and domain pairs, so there was no human identifying data in there, and so that just continued on through our pipeline. We had 9.5 billion PDNS pairs from this time period. We then went into our enrichment, join, filter, and analysis phase. We restricted traffic down to only macOS devices and to apps that had significant prevalence in our population. Overall, it took us 4,200 CPU hours and 37,000 gigabyte memory hours to process and analyze this data. There was a lot of it. So getting back to our second challenge, which was how do we tell different types of flows apart? This is a plot where each dot represents a domain port pair from Microsoft Word. And so when we think about the connections the application makes, we had this intuition that some things are going to be common, like checking for updates, while others will depend on the user, like visiting a specific professor's website. We visualize this by taking each one of these points, counting the prevalence of that flow, sorting that, and plotting it. When we do this, we can clearly see this data has some shape to it. And notice that most of this data, this blue line that are really just small dots next to each other, appear on about one device, while a few of them, where this curve is, appear on many more. And this curve is different for each application depending on its behavior. If we draw a line where the knee of this curve is, we can cut between connections that are common or endogenous to that application versus those that the user could be simulating. We use this to then build some filters that we analyze in some of these upcoming slides. So the first question we looked at was how many of an application's connections are endogenous? Using this filter, we looked at a few different measures of our data set, the number of flows, the number of domains at the second level, and number of ports, and looked at the medians of each of these before and after applying those filters. And what we notice is that there's very few connections that are made by applications that are common across hosts. And so using this endogenous filter can drastically reduce the data set size and make it easier to work with. In the paper, we also show this for things that are a little different, like browsers like Google Chrome. Happy to talk about that more about that during our questions section. Our next question we looked at was what applications are not using secure ports? So we generated a list of protocols that use secure communications like HTTPS, and then looked for each application and looked at which flows did and did not use those things on that list. And what we found is that while most endogenous traffic is secure by default, there are notable instances of prominent applications that use insecure communication channels, things like Microsoft Outlook, Jamf, which is a MDM application, and Trustee. Trustee got some attention this past fall when Twitter and blogs picked up and saw that, hey, this thing that looks security relevant is using HTTP. And we saw that as well. And it turns out that it's by design using HTTP because it's used for certificates, HTTPS certificate status checks. And if it tries to do that over HTTPS, it hits in a loop. And so it has to use an authenticated plaintext protocol instead. We look at all of these more in case studies in the paper. Next question we looked at is, are applications communicating with disreputable domains? An application communicating with disreputable domain could mean as malware or spam or something like that. And so what we did is we looked for domains from popular applications, or I'm sorry. Our next question we looked at was, are applications communicating with disreputable domains? Things like DNS sinkholes that our corporate partners manage, block lists from Snort, a list of domains from a couple different domain generation algorithms, and known spam lists from a corporate feed, a commercial feed, excuse me. And found that none of these things appeared on it, which is great because we don't want things that are really common on popular applications to be talking to these disreputable places. So to wrap up, being able to differentiate exogenous versus endogenous connections for applications drastically reduces our dataset size and gives insight into more common behavior of an application. And most endogenous traffic uses secure communications. Thank you.